Good morning everyone. In today's lecture we are going to cover the vector groups for three-phase transformers. So content we are going to cover is polarity, three-phase connections, the vector groups, verification of vector groups, and importance of vector groups. That is the application. So we are going to discuss the polarity with respect to the additive and subtractive polarity. This will be the same as we have done for single-phase transformer. If the winding of the transformer have same direction, then voltage increase of both the coils are in same polarity, that is additive polarity. If the two coils have opposite winding direction, then voltage increase of both is in opposite direction, that is the subtractive polarity. Talking about the first star connection, when each end of the coil is connected to the same polarity, it is called as a star point. The star point may be grounded or not, depending upon its application. It is usually presented by a symbol, capital symbol Y, with the vector groups. Polarity end of the one coil is connected to the non-polar end of the other. It is called as delta connection. The delta physically, the neutral point does not exist, so it cannot be brought out. The delta side neutral is imaginary point N, which is equidistant from A to B2 and C2. This is usually represented by a symbol capital D in the vector group. Vector groups are the method of categorizing the primary and secondary winding configuration of three-phase transformer and the relationship between the primary and secondary winding. The vector group primary windings connection should be shown in capital letters and the secondary winding should be shown in small letters, followed by the phase relationship of primary with respect to secondary with respect to the clock notifications. Before starting the students, I urge you to complete the relationship between phase voltages and line voltages, phase currents and line currents with respect to star and delta, and the connections between them, that is star star, delta delta, star delta, and delta star. And then we switch to this topic. Here we usually represent primary with capital, that is star in this case, secondary with delta, and the clock notification is 11 o'clock. For auto transformer we use 0 as we have concentric windings. So we are going to discuss the digit 0, that is 0 degree, phase difference between the low voltage phasor and the high voltage phasor. The second case is 30 degree, it can be lagging and leading both the cases, that is low voltage lags high voltage by 30 degree or vice versa. And then the direction will be anti-clockwise. Digit 6 represents nothing but the 180 degree lagging, that is low voltage lags high voltage with 180 degree. Digit 5 is 150 degree lagging, that is low voltage lags high voltage with 150 degree. Last but not least, that is digit 11, that is 330 degree lagging and 30 degree lagging, that is one on the same case. That means low voltage leads high voltage with 30 degree. So following examples can be done, that is dy11, yn d11, d11, that means primary is connected in star, secondary is connected in delta. Primary is connected in delta, secondary is connected in star with the angle of 30 degree between them. Primary is again connected in star, secondary is connected in delta, primary in star, secondary in star. And 0 notification, that means it can be represented as 0 degree phase difference between them. Following cases can be covered, that is 0 degree, 30 degree, 60, 120, 150, 180, 210, 240, 300 and 330. So in your syllabus you have to basically cover 0 degree, plus minus 30 degree and 180 degree with respect to primary and secondary connections. This example shows that primary is connected in star, secondary is also connected in star, and the phase difference between them is 0 degree. That is the R and second hand both have the phase difference of 0. Capital A2 represents the primary winding, secondary A2 represents the secondary winding. That means capital A2 and small a2 will be in phase and also in the star position, that is this represents Y by 0. Second case is Y 6, that means primary is again connected in star, secondary is also connected in star. The phase difference between them is again 6. So clock notification is not correct as this diagram. How are you going to draw this? The primary is connected at 12 o'clock and secondary, that is small a2, should be connected at 6 o'clock. That means the clock is going to show 6 o'clock. In phasor diagram, how are you going to represent? The primary is connected to 8 and the secondary is connected to A1. Both of them are going to show 180 degree, that is 6 o'clock, that is opposite in phase. And accordingly, anti-clockwise, you need to mark B2, C2. According to anti-clockwise, you need to mark A1, B1 and C1. So this represents the winding diagram, this represents the phasor diagram, this represents the clock notification. That means you need to show 6 o'clock in this clock, not 12 o'clock. When in this diagram, the primary is connected in star, secondary is connected in delta, the clock is showing 11 o'clock. That is 30 degree phase difference between primary and secondary, A2 and A2. That means the phase difference between capital A2 and small a2 should be 30 degree. With respect to this A2, you need to mark B2, C2. With respect to this A2, you need to mark B2, C2. And in case of delta, in case of star, you need to connect A1, B1, C1 to the neutral. In case of delta, you need to connect the ending point of 1 to the starting point of other, ending point of 1 to the starting point of other, ending point of 1 to the starting point of other. That means A2, B2, C2, A1, B1 and C1 will be connected respectively. These are the winding diagrams, phasor diagrams and the clock notification. Third case is YD1. That means primary is connected in star, secondary is connected in delta and the clock is showing 1 o'clock. That means capital notification for the primary, small notification for the secondary. So A2, B2, C2, A2, B2, C2, that is star for the secondary. So the phase difference between the capital A2 and small a2 is 30 degree. That means the clock is showing 1 o'clock. This is how you draw the diagram for star delta 1. That means primary is connected in star, secondary is connected in delta and the notification is 1. Next comes the delta and the zigzag connection, that is A2, B2, C2 and A1, B1, C1. That is primary is connected in delta and secondary in zigzag. So basically the phase difference between the A2 and A4 should be 0 degree as the clock is showing 12 o'clock. Now students, try to write this question in notebook. What is the connection for the vectors of dy11 and draw the phasor diagram. That is first the winding diagram, then the vector diagram and lastly the clock notification. Pause the video for a minute and try to draw the diagram on your own and then verify it with my solution. So this is delta, primary is connected in delta, this is star, secondary is connected in star. As the notification is 11 o'clock, the watch is showing 11 o'clock. So the phase difference between capital A2 and small a2 will be of 30 degrees. I hope everyone has drawn the correct diagram. That means you have learned the vector group perfectly so far. Importance of vector group is very important with respect to the connection diagram. If transfer of different vector group are connected in parallel, the phase difference between the secondary terminal and large circulating current flows if this connection diagram is not followed properly. So depending upon the diagram, there are different application for the 11 o'clock and 1 o'clock, that is plus minus 30 degree. Go through these applications. This is usually asked in the exam and obviously you should study from application point of view. It is usually used for step up generating station and feeding the motors and lighting load for the low voltage side. Similarly, you have application for star 0 degree and 6 degree also, that is 0 degree and 180 degree phase difference. Due to this, insulation cost is reduced and harmonics are also reduced because of the connection of star. No circulating current flows in the filter. Also, the tertiary winding stabilizes the neutral condition. Go through these applications and then try to draw the vector diagram on your own. And then we'll see in the next lecture how you have practiced it well. Thank you very much for listening to the video. Thank you.